All right, so welcome back to pre-calculus. We are working on three systems here. Uh, this is like the actual first one we have to do like the whole way through. So let's go ahead and show you what that looks like. Um, I like to put things in upper triangular. It doesn't really matter if you like upper triangular versus lower triangular. They are equivalent. So it's pretty much the difference between I like chevron versus I like polka dots versus I like stripes. Okay, I like upper triangular just because. Okay, it is completely up to you and what makes the most sense to you. You can rearrange these equations to whatever makes sense for you to do it the way that you want to do it. It really doesn't matter. So I encourage you to arrange the problem in a way or do the problem in a way that makes the most sense to you. So that's what we're going to do here. Okay, like I said, I like upper triangular, so that's how I'm going to arrange this. And there's other applications that you will learn later that when you swap things around, it will change your equation. Okay, so when you get to determinants in linear algebra, you will not want to swap things around too much because you have to track what your swaps were because that changes the value of your determinant. But since we're not going to worry about that, you don't really have to worry about that for quite some time. Until you've taken a class called linear algebra, you don't have to worry about it. Okay, so we have x plus, or we have minus 2y minus 2z equals 8. Okay, and then we have 3x minus y minus 4z equals 6. Okay, like I said, I would give this to my college algebra class and not tell them about upper triangular and lower triangular. So watch them go around in circles. I know I'm going to hell for this. But learning takes place in the moment of frustration. So the moment you want to throw your book out the window, that's the important time. Okay, that's the important moment that you're going to learn something. Okay, so embrace the frustration, embrace the suck. It happens to everybody. Okay, so there we go. And I've spent more time doing these problems than I can care to admit, but um, but that's just how you have to deal with this in order to get better at it. So the goal here is I want to put this in upper triangular. I want to X out the X's on both of these equations. I'm just going to do it one at a time because we're learning and that's just how we're going to do this. So I'm going to take my equation 1 and I'm going to add it to my equation 2. I don't have to do anything because I can see when I add equation 1 to equation 2, these X's are going to disappear. Okay, so the new and improved equation 2, negative X plus X, that's going to be 0. Y minus 2y is going to be, so we have negative x plus y plus 3z equals minus 3. We have x minus 2y minus 2z is equal to 8. Just going to add these together. We're eliminating the x's. So x minus x, that's going to be 0. Y minus 2y, that's minus y. And then we have 3z minus 2z, that's going to be a plus z. And then we have negative 3 plus 8, that's going to be a 5. So to recap, here's what we have. We have minus x plus y plus 3z is equal to minus 3. You will get faster as you do these, okay? And then we have minus y plus z equals 5. And then what do we have here? We have 3x minus y minus 4z is equal to 6. Remember the goal. The goal is to get rid of all the x's first, okay? Then we're going to get rid of the y's, and then we're going to see what we end up with. So how could I get rid of the x's? What if I multiply this first equation by 3? Okay, so we're going to have minus 3x plus 3y. Just going to multiply it by 3. Okay, so plus 9. See, there are faster ways and more efficient ways to do this. And if you do them, that's fine. Just realize that I am more prone to make mistakes if I tend to go faster. So I'm trying to be good about not making mistakes here. So we have 3x minus y minus 4z is equal to 6. And I'm going to add my equation 1, my equation 3 together. We're going to get our new equation 3. So negative 3x plus 3x, that's 0. We have 3 minus 1, that's 2y. We have 9 minus 4, that's going to be 5. z, that's going to be a positive. Okay, and then -9 plus 6, we end up with a -3, I believe. Okay, so to recap and to summarize, we didn't change equation 1 really, so we still have our -x plus y plus 3z is equal to -3. We have our -y plus z, so we have -y plus z equals 5. And then our new and improved equation 3, we have 2y plus 5z equals -3. So yes, there is a more efficient path to do this, and if you want to do it that way, I am not going to get mad at you. You can go ahead and do it more efficiently. If you're just starting off with this, I would suggest kind of taking it slow and doing one step at a time and laying everything out so you don't get lost. Okay, so notice there are no x's. To get this in the upper triangular, what I want to do is I want to remove the y's parts. Okay, so what I'm going to do is I'm going to multiply everybody in equation 2 by 2. Okay, so we have minus 2y plus 2z equals 10. What is my equation 3? It's 2y plus 5z equals -3. Okay, so there we go. Double checking to make sure that I have everybody straight here. And then what we're going to do is we're going to add these two together. Notice the y and the 2y make 0. That's the point. So 5y and 2y is 7z. 10 minus 3, 7. So to recap, okay, we have our -x plus y plus 3z equals -3. We have our -y plus z equals our 5. And then our, let's get rid of that because that's not really a minus there. Okay, so there we go. And then our final thing, we have 7z equals 7. So again, notice we have this nice upper triangular shape. If you wanted to do it in lower triangular, there's nothing wrong with that. You're going to get maybe the backwards equation here, but you're still going to end up with a z equals 7, or z equals 1 rather. And then we can go ahead and substitute this out. And then what we're going to do is we're going to back substitute all the way back up and then see what happens. So we have -y plus z, that was 1, is equal to 5. We'll subtract 1 from both sides. So we have -y is equal to 4. So y is equal to -4. Okay, and then back up by 1 more. So we have -x plus y. Y is -4. Okay, plus 3. What the heck is z? Z is 1 equals -3. Okay, and then we're just going to solve for x here. So we have -x minus 4 plus 3 equals -3. If you want to substitute this and make this a little bit easier to work with, that's fine. So it's -x minus 4 plus 3 is -1, I believe, equals -3. Add 1 to both sides. So we have, this is a semicolon, -x equals -2. So x is equal to 2. Okay, so our triplet, I hope this one works out correctly. We have x is 2. We have, what the heck was y? Y was -4. Okay, I was -4, and then z was 1. Okay, and that's going to be my solution here, and I'm hoping that this actually works this time. So we have 2, -4, 1. So 2, -4, and 1. We could check it. We can check this thing and make sure that it actually worked. Okay, but you don't have to. It's fine. Okay, just going to check. Hey, look at that. We got the little green check mark, so we should be good to go, and then we'll continue. So I'm going to go ahead and let you go with this one, and we'll see you in the next video. Thank you.